Look at these two aircraft. Same fuselage, same turrets, same nose, same engine positions. One is American, one is Soviet. Built on opposite sides of the world, years apart, by engineers who had never met. Most people glance at that and assume the Soviets just lacked the skill to design their own. That assumption is wrong. Stalin had world-class engineers. He had Tupolev. He chose to copy anyway, deliberately, personally, under pressure that most people today do not fully understand. The reason has nothing to do with incompetence. It has everything to do with a clock that was already running. In photographs, the Tu-4 and the B-29 are nearly impossible to tell apart. Same pressurized fuselage cross-section. Same twin-bubble gun turrets. Same curved nose glazing. Same engine nacelle positions along the wing. If you put the silhouettes side by side and remove the markings, most aviation experts would need a moment. That level of similarity does not happen by accident, and it does not happen through inspiration or influence. It happened because Tupolev's engineering team measured, cataloged, weighed, and duplicated tens of thousands of individual components from 3 real B-29s, down to the oxygen fittings, down to the wiring brackets, down to the crew ashtrays bolted inside the cabin. People hear that and laugh. Ashtrays. But that detail is the whole point. When the order is copied exactly means everything. And understanding why Stalin gave that order requires going back to where the 3 aircraft came from in the first place. 3 B-29s. That is where this story actually begins. Between 1944 and 1945, American bombers conducting raids over Japan encountered damage, fuel shortages, and mechanical failures that forced emergency diversions. The Soviet Union was neutral in the Pacific War at that point. When damaged B-29s landed on Soviet territory, the crews were interned and eventually returned. The aircraft were not. Stalin had them. 3 intact examples of the most technologically advanced bomber the United States had ever built. The question was what to do with them. The obvious military answer was to study them, learn from them, understand what made them different. But Stalin's answer went further than that. And to understand why, you have to understand what the B-29 actually represented in 1944. Because it was not just an aircraft. It was a category of capability that did not exist anywhere else on the planet. The B-29 Superfortress was not a conventional bomber scaled up. It was a pressurized, high-altitude strategic platform that could fly higher, farther, and carry more than anything the Soviet Union had or was close to building. It had a pressurized crew tunnel connecting the forward and rear compartments. It had remote-controlled gun turrets managed by a fire control system. It had fuel-injected engines with sophisticated cooling. It was, by the standards of 1944, an extraordinarily complex machine, and the United States had built nearly 4,000 of them. That production scale alone was a statement. The Soviets were looking at something that was not just ahead of them technically. It was ahead of them industrially, systemically, and doctrinally. And then August 1945 arrived, and everything about that gap became urgent in a way that no military planner could ignore. The easy answer, the answer most people assume, is that Soviet engineers simply were not capable of building anything equivalent. That explanation collapses quickly when you look at what the Soviet aviation industry actually produced during the war. The Il-2 ground attack aircraft was built in larger numbers than any other military aircraft in history. The Yak-3 was competitive with the best German fighters at low altitude. Soviet engineers like Ilyushin, Yakovlev, and Tupolev himself were not passengers in aviation history. They were serious designers producing serious aircraft under conditions that would have shut down most Western programs. Evacuated factories, freezing temperatures, material shortages, and continuous production pressure simultaneously. The problem was not capability in general. The problem was one specific gap in one specific category, and that gap had just become catastrophic. August 1945. The United States dropped atomic bombs on Hiroshima and Nagasaki. Stalin understood the implication immediately, and the implication was not just about the bomb itself. A nuclear weapon without a delivery aircraft is not a deterrent. It is a storage problem. The Soviet Union had no aircraft that could carry a nuclear payload to a meaningful target at strategic range and altitude. The B-29 could fly at over 30,000 feet, carry enormous payloads, and operate at ranges Soviet bombers could not approach. The gap between what the Soviet strategic bomber program could deliver and what the B-29 represented was not a small engineering problem. It was the difference between being a nuclear power and merely claiming to be one. Stalin had watched the United States end a war in 2 strikes. He was not going to wait 8 years for a Soviet equivalent to emerge from a clean sheet design process. Stalin wanted a solution in 3 years, not 5, not 8, 3. Designing, testing, and certifying an entirely new strategic bomber from scratch, with new engines, new pressurization systems, new defensive armament, new production tooling, was a minimum 5 to 8 year program under the best conditions. The Soviet aviation industry in 1945 was exhausted from 4 years of war production. Factories that had been relocated east of the Urals to escape German advances were still running on emergency footing. The engineering teams that might have started a new strategic bomber program were stretched across recovery, reorganization, and the immediate demands of a post-war military that needed everything rebuilt at once. The answer Stalin chose was not to design a bomber, it was to become the B-29. Tupolev was handed the 3 aircraft and an order that left almost no room for interpretation. Copy it. Not inspired by it, not improved from it. Copy it. The story goes that Tupolev pushed back, carefully, because pushing back against Stalin required a certain kind of nerve, and suggested that Soviet engineers could design something original that incorporated the B-29's best features while fixing its known flaws. Stalin's response was direct. He did not want something better. He wanted something now. The distinction mattered enormously because designing something better takes longer than copying something proven, and time was the one thing the Soviet nuclear program could not afford to spend. So Tupolev's team went to work. Every measurement converted from imperial to metric. Every material specification translated to Soviet industrial equivalents. Every American standard component matched to something Soviet factories could actually produce. The team pulled panels off the fuselage and measured individual rivet spacing. They weighed structural members to the gram. They traced hydraulic lines from origin to terminus. They documented wiring runs, junction boxes, connector types, and insulation grades. They pulled apart the engines and cataloged every internal component. They recorded the crew compartment layout with the same precision they applied to the wing spar geometry. The result was a parts catalog of extraordinary detail, a complete Soviet-language engineering record of an American bomber that American engineers themselves could not have produced so comprehensively, because American engineers had built it in sections across dozens of contractors and never held the whole picture in one place. The logic behind exact copying was not laziness. It was aerodynamic risk management. The B-29 was a known quantity. It flew. It worked. Its performance envelope was documented in American operational data that Soviet intelligence had partially accessed, and in the direct observation of the 3 aircraft themselves. If you modify a structural element without understanding how it interacts with everything around it, you introduce unknowns into a pressurized aircraft operating at altitude with a nuclear payload. A change to a fuselage frame affects skin stress. A change to a control surface affects handling at altitude. A change to an engine mount affects vibration characteristics across the airframe. Stalin's deadline did not allow for years of flight testing to validate a chain of modifications. Copy it exactly, and you inherit the performance envelope along with the rivets. Change something, and you own whatever problem follows. But copying exactly was not actually possible, and this is where the project became genuinely difficult in ways that the simple phrase bolt for bolt does not capture. American aluminum alloys had different compositions than Soviet equivalents. The specific grades used in B-29 structural members contained elements in proportions that Soviet smelters did not produce to the same standard. Direct substitution changed structural properties in ways that had to be tested and accepted or rejected one component at a time. American fuel grades differed from Soviet aviation fuel, which shifted engine behavior at altitude and affected range calculations. Rubber compounds used in hydraulic seals and pressurization gaskets had no exact Soviet matches. And on a pressurized aircraft, a seal that behaves differently at 30,000 feet is not a minor variation. Wiring insulation, hydraulic sealants, coolant compounds, lubricant specifications, none of these had perfect Soviet equivalents. Every substitution required a decision about how much deviation was acceptable on an aircraft where the wrong answer kills the crew at altitude over a target city. Tupolev's team made thousands of these decisions. The process took longer than copying should have taken precisely because copying was never actually copying. It was continuous translation between two industrial systems that had developed independently for decades under different material constraints, different production philosophies, and different engineering standards. Some Soviet material substitutions performed slightly differently than the American originals in ways that were measurable but acceptable. A handful performed marginally better in specific conditions. Soviet aluminum in certain structural applications proved adequate in ways that surprised the engineers doing the comparison. The aircraft that came out the other side looked identical in every photograph, identical in every silhouette, identical in every external measurement. But it was quietly, invisibly, a different machine in certain technical properties, and the men who flew it operated with that knowledge. It flew anyway. The Tu-4 entered service in 1947, achieving Stalin's timeline with enough margin that the first operational units were forming before the deadline expired. When it appeared in the Soviet Aviation Day flyover that year, American intelligence analysts stared at the reconnaissance photographs and needed a moment to accept what they were seeing. The aircraft that NATO would designate Bull was, in silhouette, the aircraft that had firebombed Tokyo and delivered the bombs that ended the Pacific War. The psychological effect on Western strategic planners was significant and immediate. The Soviet Union had demonstrated that American technological advantages could be replicated, that the lead time between American capability and Soviet capability was shorter than anyone had assumed, and that the gap which had seemed comfortable in 1945 was not a permanent feature of the strategic landscape. Over 800 Tu-4s were eventually built. The production scale itself was a statement. This was not a prototype program or a limited demonstration. This was a strategic force. In 1951, the aircraft was used to drop the first Soviet nuclear device in an air-delivered test, validating the delivery system that Stalin had demanded and that Tupolev's team had built from 3 diverted American bombers, and in order to copy everything including the ashtrays. The deterrent existed. The clock that had started running in August 1945 had been answered. But the Tu-4 carried a problem that the bolt-for-bolt logic had baked in from the beginning and that no amount of Soviet manufacturing precision could solve. It was a 1944 American design. By the time it entered Soviet service in meaningful numbers, jet interceptors were already in development on both sides that would eventually make high-altitude piston engine bombers vulnerable in ways they had not been during the war. The aircraft was approaching obsolescence before its production run was complete. Worse, the range problem was fundamental and unsolvable through modification. The Tu-4 could not reach the continental United States from Soviet territory and return. The distances involved, the fuel loads required, the payload constraints, the arithmetic did not work for a two-way mission. Crews assigned nuclear delivery roles against American targets understood the operational reality of what they were being asked to do. The Tu-4 was a deterrent built on a one-way calculation, and everyone involved knew it. That limitation was not a secret, and it was not a failure of the copying process. The B-29 had the same fundamental range constraint when measured against intercontinental distances. It was a theater bomber that happened to be the most capable aircraft available, not a purpose-built intercontinental platform. Copying it exactly reproduced its capabilities and reproduced its limits with equal fidelity. The Soviet Union got exactly what it had copied, which was simultaneously a genuine strategic capability and a genuine strategic constraint. The Tu-4 bought time, and the price of that time was paid in the years it took to develop the jet-powered successors that could actually reach American territory and return. The Tu-95 and the aircraft that came after it carried the payload capacity and the range that the Tu-4 could never provide. What Tupolev's team did not fully anticipate, what nobody in 1945 could have anticipated, was what they learned in the process of copying. Reverse engineering the most complex aircraft the United States had ever mass-produced turned out to be an education in manufacturing precision, systems integration, and quality control that Soviet aviation had never been forced to confront at that scale and in that compressed timeframe. The tolerances the B-29 demanded were tighter than Soviet production culture had standardized around. The systems integration it represented, pressurization, electrical, hydraulic, armament, navigation, all working together reliably at altitude, required a level of component consistency that forced Soviet factories to operate differently than they had during the war. Working through all of that at the component level, making thousands of translation decisions, testing substitutions, validating performance, it gave the engineers who built the Tu-4 a manufacturing and systems foundation they applied to Soviet aviation programs for the following decade. The copy taught them things the original designers never had to learn, because the original designers built it forward, while Tupolev's team had to understand it backward. Look again at those two silhouettes. Same fuselage, same turrets, same nose. The strangeness of it, the ashtrays, the oxygen fittings, the bolt patterns, the rivet spacing, is not evidence of failure or imitation or inferiority. It is the physical record of a decision made at the exact moment nuclear weapons changed what a strategic bomber had to be and how quickly it had to exist. The detail that makes people laugh, the ashtray, is actually the most honest part of the whole story. When you are copying something under that kind of pressure, for those stakes, you do not stop to decide which parts matter. You copy everything, because you do not have time to find out what you missed. They didn't copy the B-29 because they couldn't build their own. They copied it because, in 1945, the clock mattered more than the credit. If this is the kind of story you didn't know you needed, there is another one waiting. The next video covers something just as strange, just as specific, and just as misunderstood. It is already up. Go watch it.